Hi, this is Alex from devstories.eu. GeoPandas, Episode 10 of 11. You do not need to export your spatial data to heavy desktop GIS software just to see what it looks like. You can generate publication-ready visuals right inside your Python environment. The solution is static mapping, building choropleths and plotting layers. The core of visualization in GeoPandas is the plot method. Every geodata frame has it. Calling plot with no arguments immediately draws your geometry. It is effortless, but under the hood, it wraps Matplotlib. This means you get a map in one line of code, but you still have the full power of Matplotlib available to tweak colors, axes, and styles. A basic plot just draws shapes. To make a choropleth map, where shapes are colored based on data values, you use the column argument. You pass the name of the column containing your data. GeoPandas will map the values in that column to a color scale. To help viewers understand that scale, you can add a legend by passing legend equals true. By default, plotting a continuous numerical column creates a smooth color gradient. Often, it is better to group your data into distinct bins. GeoPandas integrates with a library called Mapclassify to do this. By adding the scheme argument to your plot method, you can sort your data into classes. For example, setting scheme to quantiles splits your geometries into equal-sized groups based on their values, making spatial patterns much easier to read. Real-world datasets often have holes. If you are building a choropleth and some rows are missing the data value you're plotting, GeoPandas will drop them from the map entirely, leaving awkward blank spaces. To fix this, you use the missing keyword argument. You pass a dictionary of styling options, like setting the color to light gray, so those shapes still appear on the map without confusing the data. Now, the second piece of this is overlaying multiple datasets. Most useful maps combine multiple layers. Suppose you have a base layer of city neighborhoods and you want to overlay a scatter plot of grocery store locations. You do this by sharing a Matplotlib axis object. First, you create an axis. Then, you plot your neighborhood polygons, passing that exact axis into the plot method. Next, you plot your grocery store points, passing that exact same axis. Both datasets draw onto the same canvas. To control which layer sits on top, you use the z-order argument. A lower z-order goes to the bottom, so you give your neighborhoods a z-order of 1 and your grocery stores a z-order of 2. The points will render cleanly over the polygons. Pay attention to this bit. Sometimes you want your base polygons to be completely transparent, so you only see their borders. If you set the face color argument to none as a Python object without quotes, Matplotlib ignores it and applies a default fill color. You have to set face color to the string word none to make it transparent. Alternatively, you can bypass this entirely by calling the boundary property on your geodata frame and plotting that instead. It's a much safer approach for drawing just the outlines. The true strength of mapping in GeoPandas is its seamless escalation from quick data checks to publication-ready graphics. You get an immediate visual with a single method call, but never lose the underlying control of Matplotlib when you need to layer complex spatial stories. That's all for this one. Thanks for listening and keep building.